So question 17, they give us 3 different compounds and they ask us which 2 are enantiomers. And so I start with molecule 1. So here's molecule 1. So to find an enantiomer, we basically need to find the mirror image of that molecule. And they make it hard for us because instead of just flipping the molecule through, so if we flip this molecule through a mirror, this would be the mirror image over here. The hydrogen is behind us, the alcohol is coming forward. So in the enantiomer, those need to switch positions. So if the alcohol is coming forward in the mirror image, the alcohol needs to be going into the page if we flipped it through a mirror image. So this structure, which is the mirror image of structure 1, is not there as we see it. They do it a little bit differently in that in doing the mirror image, you basically are switching the stereochemistry. So we're looking for one where, okay, if bromine is going into the page, in the enantiomer, bromine needs to be coming out of the page. So, okay, I need to flip that stereochemistry. And then if the alcohol is coming out of the page, right, like we see here, alcohol needs to be going into the page. So we need to flip that stereochemistry as well. So that enantiomer, if I draw it the same way, that enantiomer would look like, right, CH3. I need to have the alcohol going into the page, the hydrogen coming out. And then that means I also need to have the bromine switching as well. So the bromine needs to come out of the page and hydrogen needs to go in. So this would be the enantiomer of the first compound because I switched the stereochemistry at the first carbon, right? Bromine is now pointing out where before it was pointing in, and the alcohol is pointing in, whereas before it was pointing out. And if we look at those choices, right, this is choice, or that's molecule 3. So molecule 1 and 3 are enantiomers of each other because both chiral positions, we've switched the stereochemistry of both of those chiral positions.